So the brain decides that it wants to contract a muscle, so then it travels through like the spinal cord and then like the nerve, and then it hits the motor neuron. And then the motor neuron, so like say this is a motor neuron, there's like a little voltage gated calcium channel that once the action potential travels through and it hits that, it opens this channel and then the calcium can flow through. So calcium can flow through this channel. And then once the calcium flows through, it hits, this is a horrible drawing, it hits the synaptic bulb. And then in the synaptic bulb, you have synaptic vesicles, which contain inside of them, you have acetylcholine inside. And so then once the calcium comes in here, the acetylcholine is exocytosed into the neuromuscular junction, or the synaptic cleft. And then once it hits like right here, it passes to the neuromuscular junction and then lands on the sarcoplasmic reticulum. And then, so the acetylcholine comes through and it's exocytosed onto the sarcoplasmic reticulum. And then here, there's a ligand-gated channels where where are the acetylcholine receptors?
They're just on the sarcolemma.
They're just here, okay. Mm-hmm. So here you have like a bunch of acetylcholine receptors. So the acetylcholine binds with the receptors, which causes the acetylcholine to pass through, which then...
Just called what channel?
The ligand-gated channel.
Good.
Which causes the influx and efflux of sodium and potassium. And then this is like
and so if you want to be like super precise here, so calcium is 2+, sodium is just plus.
Oh, that's
and then
fine.
and then potassium's also plus. But that's not like super important.
It might be. And so yeah, that looks so much better. Okay. And then once the propagation of the influx of sodium and the influx of potassium, that creates another action potential. And so we're still like on the sarcoplasmic reticulum. So this is all the sarcoplasmic reticulum. And then let's see how I draw this. Then once that action potential like is created, then on these like this thing right here is the T tubules, and then this action potential rushes into the sarcolemma, which is like this.
So
No.
This is all the sarcolemma, and then this is the sarcoplasmic reticulum.
Ooh, I got this wrong.
Sorry, I should have caught that sooner.
No, it's fine. It's totally fine. I might just have to do this again, honestly. So this is the sarcolemma. This is the sarcoplasmic reticulum.
Yes.
And so that action potential goes to the sarcoplasmic reticulum, which is inside the T tubules. Am I missing a step?
Mm-mm.
No. Okay, and then once, so then there's gonna be, okay, let me just do this. Here, there's gonna be other voltage gated channels. This is calcium again, right? Okay, more calcium gated channels. This action potential causes calcium to pass through. And then once this calcium passes through, it flows to the actual muscle cell. And then in the muscle cell, which is called the myofibril, just gonna make this bigger. You have actin, and then I'm just gonna say at the looks weird, and then myosin. And so with this calcium that's come through, it causes the binding of, sorry, I'm totally in the way of this. The binding of a complex, which is tropomyosin and troponin.
Mm-hmm.
And when tropomyosin is present, that means the muscle's relaxed. But when this calcium comes through, the tropomyosin is essentially blocked. So I'm just gonna cross it out, which means that there's an open active site, or there's an open site on the actin, which this myosin head essentially binds to, and this action is called a cross bridge.
And what does it need as well?
It needs 1 ATP. Good. And so once it binds, when they say the sliding filament theory, it's the actin is essentially pulled by the myosin head, but it slides, and that is called the power stroke. And so once it pulls over, the releasing of the cross bridge, I guess you could call it, so that the myosin head no longer touches the actin,
Mm-hmm.
it's undoing the cross bridge, and that uses 1 ATP as well.
Mm-hmm.
So, and then it exposes another site on actin, and it just keeps doing that,
Mm-hmm.
essentially.
And then how do you relax the muscle?
Okay, yeah. So to relax the muscle, this is where it's gonna get kind of complicated, I think. So the acetylcholine is released just like how it's released before in this process,
Mm-hmm.
but acetylcholinesterase is also released, and that doesn't.
It breaks down
It
the
breaks down the
acetylcholine.
acetylcholine.
Mm-hmm.
And then the acetylcholine is broken down, which if there's no acetylcholine, then there's no influx in.
So
Am I
the
getting this
breakdown of the acetylcholine kind of triggers the sarcoplasmic reticulum to absorb the calcium.
Okay, that makes sense. Yeah.
So then,
because there's no action potential that opens the.
yeah.
Yeah. Okay.
So it reabsorbs the calcium, and then that since there's no calcium.
Yeah, this can't happen.
Exactly.
So there's no calcium, so that means that tropomyosin is still on actin.
Yeah,
Or
it
there.
comes back or is unblocked, however you want to call it. And then that relaxes the muscle, because tropomyosin is ultimately the thing that relaxes the muscle.
Yeah.
And that's it. Look at you. You're so good.